Hey guys, welcome back. Today in this video, we will talk about Hashable and Hasher as an interview question. So you've been asked in interview, what is Hashable protocol? So what will be your answer? So in interview, when they ask you a question, you have up to 5 minutes maximum to talk about the subject, because if you take it more time, then you lose time for other question, and if you lose any question, you get 0 point for that in competition with other candidate. So in less than 5 minutes, you need to transfer all of your knowledge to your interviewer in a way that convince them that you are comfortable about this subject. Also, uh, kind of impress them. So, what is Hashable in Swift? Hashable is a protocol that we can conform our data type to it, and a type that can be hashed into a hasher to to produce an integer hash value. Okay, so if you say this, it's the end of the story? No. I tell you why. Because first of all, they're not gonna start from this point. Maybe they ask you from other ways to make you a little bit confused, or even the way that they find it in Google. So what is hash? What is hash table? What is hashing? What is hash algorithm? What is hash collision? What is hash flooding? How store elements in a set or dictionary, or how do you store sequence of objects in a way that if you are looking for any element, you find it in constant time. O notation 1, not O notation n, because by normal, when you look at an array, it's take O notation n. So you can answer all of this question when you explain Hashable. Also, so you can start from by this way. To answer your question, if they ask you all of this question, you can say, to answer your question, let me explain Hashable, and in the specific point, I will go over your question, if it's okay. And if they tell you yes, go ahead, then you can move forward. Also, there's another advantage by this approach, because sometimes your interviewer is not really kind of knowing the answer. Just Google question for Swift interview senior, and they found that question, and just description below which is answer. So they're expecting you tell them that one. So if you don't say that, then you lose that point. So if you explain, then not only they understand the subject, but also you can impress them. Okay, so for diving, first of all, we need to know these terms. Hash, also known as a hashes or checksum. It is the result of hashing algorithm. So hash or hash value, it is result of hashing algorithm. So hashable, that we are is our main topic. An object is hashable if it has a hash value that is the same for the lifetime of the object. This is the key point. Lifetime of the object is not going to change. Hash table. You may hear a hash table even in the other languages a lot. So a data structure that map keys to value. So based on the value of the elements or objects, key will be get value. Hash function. So we talk in here, we said hash function. A hash function is a function that generates hash value. Any hashable objects need to have hash function that get object, give us, here you go, just show you. So get the element or item or object and give you a hash value. Okay, so hashing algorithm. Inside hash function, we have an algorithm that generates hash for us. And set. In Swift, we have collections, of values, which is on order, and their location of the each element is based off of the value of that element. And of course, in set, the values are the same type. And type a representation of the type of data that can be proceed. So like integer and string. Okay, so let's start. Hashable is a protocol that we can conform our data type with it. Okay, so it is a protocol, first of all. And why hashable? So why we gonna conform our object to hashable? We do that because if we want to store our elements in a set or dictionary, the basic reason. Or you need to conform hashable protocol, although Swift can synthesize conformance after Swift version 4.2 is doing itself. But it's an advantage that you know that how you can do this manually. So here I show you two hash table. This one poor and one rich. So this one is a poor hash table, and you will see that our index for several elements is the same. This is not good because this is gonna be we're gonna lose data here. And here we have one rich one that you will see that elements either each of them have separate index. Okay, hashing. So the action of converting our elements or pulling out hash value is hashing. And hashing being done by hash function. So hash function, inside hash function, we have hashing algorithm. So we have several well-known hashing algorithm, MD5, SHA1, SHA2 are one of the most common. And the map data to hash into the form of one-way function that should be feasible to invert. So this hashing algorithm doing this, and an extension of this is use a hashing algorithm to index data to a hash table. So for indexing, we're using hashing as we said so far, hashing algorithm we use. And here I'll show you some hashing algorithm, MD5. You can see a graph. You don't need to memorize this, but good to know, and maybe a start point being one of this in your interview. And this is SHA1, and this is SHA2 graph. And here I just gather a list of some more hashing algorithm with some more specification and more details. And here is compare of speed between some of them. So you can see MD5 is the middle and SHA3-512 is the best, and the worst is SHA1. So you can get idea, because when you're doing choosing a hash table, hashing algorithm, it's very important. It's if you choose one slow one, gonna make the data structure slow, your program is slow, or depend on how big is your data collection. And if your data collection is small, you can use a slow one, but if they are big, it's better to going from this or this. Also, before I go to programming part, I want to give you two more terms: hash collision and solution for that, hash flooding and solution for that. So hash collision. Two objects produce a hash collision when they have the same hash value but aren't equal. So we have two objects that they are not equal, but their hash value are equal. This is hash collision. And when collision occur, an intersection, they're stored in a list at that address. So both of them will store in a list in that address. The higher the rate of a collision between objects, the more linear the performance of a hash collection becomes. And for solution for hash collision is to selecting better algorithm inside hash function. So you need to change your hashing algorithm to find something better. And hash flooding. Hash flooding is a DOS attack. So when your hash collision, hashing algorithm is poor, then attackers can use DOS attack to bombard your program to have more and more hash collision, and this when they increase, your program going to be slow, and the 1 point is maybe halt. So for example, it's happened in 2010 that bunch of problem we had over the web with this hashing flood. So again, solution is to selecting cryptographic algorithm like SIP hash that we already in Swift 4.2 and after using this. Okay, so let's go and start our coding. First of all, I explain this to you, and then I will go and do it in Xcode. So just consider we have this structure, color, which has the we have red, green, and blue, all int 8, unsigned int 8, and we want to make this hashable. But our Swift version is before 4.1. So what we do, first of all, we need to make it equitable. So what we do, we override extend that that one bit equitable, and we override this function which is comparing two elements before and after itself, and then result will be a boolean that they are equal or not. And then we're gonna go for hashable. When we do conform it to hashable, then we need to override hash value and to pull out our hash value. So this is our algorithm here, okay? And then the result in 4.1, you will see that these two colors are equal, which is not true. So this is a hash collision. But after 4.1, it's super easy. You just make it hashable like this and done. But if you want to make it customized, okay, so now hasher enter and help you to make it more customized. So here we do hashable, then compiler synthesize it like this: hash into is instead of hash value, we will override hash into function with hasher that combine, and here hash value will get hasher dot finalize. So this give us more customized, and you can even change this. And here when we check the same two color, you will see that they are not equal. So now we fixed that. This is another one that you can create it. I just show you here, and then you can do it yourself. So here we create we can write your own hashable type. So for like a person with name and age, and then if you want to conform it, we store it as a set or dictionary. We cannot be able to do that. Just make it hashable and done. If you want to make it customized, you can write down this part manually. Okay. So yeah, let's go to our Xcode and start a project. So I start one project by the name of interview Swift Hashable. I'm gonna push this to GitHub, and you can find source code in there, and link will be in comments below. So here what I do. So first of all, we will have one. Actually, I choose the a storyboard. You can choose SwiftUI. But in this Mac I have an old version of Xcode, so I have to go by this one, but not much different with SwiftUI. So what I do, first of all, I'm gonna write down my structure. So just say structure color. I'm gonna do it for different versions, so color 0, 1, and 2. So color, and I just say let red unsigned int 8, and again let green unsigned int 8, and let blue from type of unsigned int 8. So this is my structure. So in my excuse me, in my view did load, I just want to do something, so I just say okay, let's create. Actually, let me have it here. I'm going to copy paste to make it faster. Okay, maybe if I type it, it's going to be much faster. Okay, so now I want to see value, if they are equal or not. So print, and here I just say value equal / open and close parentheses. So here I can use value. So here I see I don't have hash value. Yeah, because I didn't conform it there yet. So how can I fix this? I need to make this extend this actually this struct to hashable. So I'm gonna extend it extension color 0 hashable. It's not gonna be happen. Why? Because say first you need to actually, yeah, because my Swift version is after 4.2, so it is okay. So what I do, let me here just comment this. Okay, so here I made it and it's got it because my Swift version is 4. Let change it and see. So build setting, here Swift version 4.2. I make it 4. Okay, now here I should get error. Command B. Yeah, build succeed. Interesting. Technically, by theory, I shouldn't be able to do it. Anyway, so you're gonna make it equitable first. If your version is before 4.1. And so for make it equitable, you do this part. So you say LHS and left HS and right, which both get that color 0, and gonna compare, and if they are both red, green, and blue are equal, say they are equal. Then I'm gonna extend to Hashable. And in Hashable, what I need to do, I need to write my hash value. So in my hash value, I say static, no, not static, sorry, it's variable hash value int, which type of int, and here computed the property, and I just say return value. So what is the value? Is self dot red dot hash value, because red is a hashable type and object, so I have hash value. Then I'm gonna end this with self dot green dot hash value and self dot blue dot hash value. Okay, so yeah, sorry, here I should use this, yeah, to convert it to integer. Okay, now if I come here, uncomment this, and say, okay, this one, hash value of that, yes, I have it. Yellow. Also, I say, okay, compare them and tell me in one if else that if they are equal or not. Okay, so let's run this. So here in console, I will see value of either each of them. So you say yellow, they are equal. This value and this value is correct. So we have hash collision now. So to fix this, we can use now I just say struct color 1 hashable, because my assumed version of Swift is now after bigger than 4.1, equal and bigger. So here I just declare all the same Okay, and so now I make a copy of all of this. And I name this 1, 1, 1, color 1, color 1, 1. And yeah, 1, 1. Yeah, now I run it. I got error here. Unresolved identifier. So I think I had a mistype here. Yeah, it should be capitals. Okay, run it. Here you will see that now they are not equal. I just used compiler Swift equitable hashing algorithm technically. But I can go further. So what I can do now, even I can write down this customized like this. So you will see Hashable. It's synthesized by compiler. What I can write down here, overwrite it, and here I make it myself. This is default implementation, but you can change this. Whatever you want, you can change. But this is what it's doing, and I just override it with the same it is. So now I come here and so I do number 2 for all of this. I just copy paste because I want to make it faster and make sure video length shorter. Okay, let's run it again. Yes, stop and run it again. Here you are. You will see that number 2 and 1 I did it manually myself, and as it is by default inside compiler are the same, but the result that we are looking for is that we don't have hash collision anymore. So you can play with this function and this algorithm to make it more customized as you wish, or any other hashing algorithm you like to use. Okay, thank you for watching this video. That's it for today. I hope you like this video. Please share your knowledge, your question, even if you have any correction, any advice, any issue, any request, and comment below. You're always welcome. Also, please share if you want to add